All right, squaring it. So if I hit enter, it's basically running like a calculator. So it takes the number 6378, 6,378, and squares it and gets a number about 41 million. So I'm going to take these commands fairly methodically, step by step, so people don't get behind. And please, if you have a problem or a question, speak up, because we have another hour or so, hour and a half, hour and 10 minutes to work on this. So if you have a question or a problem, please let me know. And I want to make sure everybody's at least at this stage now where they've got the R console window running. And if I don't hear from people, I can assume that everybody's okay. They can hear me, they can see, they're running what's on the screen. Let's take that number. Now, one of the things you can do, and you can't see me doing this, but if I hit the up arrow key, you can see I've hit up the up arrow key twice, and I'm back at the original number or command that I entered. If I hit the up arrow key once, I'm back at the command, the second command I hit. So if I use up arrow, you can either use up arrow or you can just type it in again. So we've got this command 6378 squared, and I'm going to multiply it times 4, and I'm going to divide it by 3. So I've got a syntactically correct R command, and when I type 6378 squared times 4 divided by 3, I don't need parentheses with multiplication and division, I get the product of 6378 squared times 4 divided by 3, which you may wonder why I'm doing that, but I'll show you in a minute. Well, R also comes equipped with a whole bunch of constants. For example, our very good friend pi. So if I type pi, I just type in the command pi, and I enter, and it gives me a constant, 3.141593, and so forth. It probably gives it to however many places you want it. But if I type in, say, the letter pi, I mean the word pie, which is one of my favorite foods, it actually looks like pie actually means something. So let's talk about apple pie. Apple. All right, so the concept of apple is not fine. There's no object representing apple in the R environment. There is pie, but nothing for apple. And again, I can hit the up arrow key each time and get all the commands that I've been typing in from the very beginning. So if I go all the way up, there's my 6378. And the last command I typed was pi. So I'm basically using R as a calculator, and it has a memory, but only if I put things into its memory. So it doesn't remember my 6378 because the 6378 is not an object. But we do know that there is an object in R called pi, but there's nothing else that we've created. In fact, I guess I won't do that. Let's not confuse things. All right, so let's create an object called R. It's not the language R, but so if I hit R and I hit return, it says there's no object R in memory. But I can take R and assign it the number 6378 and hit return, and nothing happens. With the effect, if nothing happens, is a good sign. It means that the R processor didn't mind what we typed. But it turns out what we have done is we've taken the number 6,378 and assigned it to the letter R. So now if I type the letter R, I get back 6378. So I've put the number, the scalar, the integer 6378 into the object R, and the R maybe not a good choice, but maybe not a good choice of letters, but so I've got the letter R, and now I can square it, which is the same answer we got when we typed out the number, and I can multiply it by 4, and I can divide it by 3. And I can multiply it by pi. Okay. So there I've got R squared times 4 divided by 3 times pi. Does anybody know why I'm doing that? Anybody care to guess why you might take a number, square it, multiply it by 4, divide it by 3, and then multiply the product by pi?
The volume of a sphere?
I think it's the area of a sphere. But good, that's a great answer. I mean, that's a chance to show how smart I am by saying yes. Well, that's a good answer. So we've got the area of a sphere whose radius is 6,378. So what sphere has a radius of 6,378 somethings?
The Earth?
Right. So what we're looking at is this expression, which I'm going to give it the value A. So let's go back to that command. I just do up the up arrow or whatever it is on your computer, and then I let that object, I create a new object called A, and now I've got the area of the Earth in square kilometers. It's a little hard to determine how many digits there are, but what I can do if I want to figure out how big a number that is, I can say type in log to the base 10 of A, and it says it's 100 million square kilometers. It's almost 100 million square kilometers. Because if I do 1 and 1, 2, 3, that's 6, 7, 8, 9, that's 10. So that's all right. So if I type in the number 10 million, I get 1E7, which is close to the value that we. I guess we want one more, so it's 1E8 would be. If I divide 1E8 divided by R. Oh, I'm sorry, by A. So it's about twice 100 million square kilometers. So I've got a value A in memory. I've already got the letter. I know that pi is in memory. And if I wanted to say, look at what would be the area of what would be the side of a square with whose area is the area of the Earth, I could just do square root SQRT of A. So that tells me that a square with about 13,000 kilometers on a side would have the same area as the planet Earth. So it's a good, just a kind of a good thing to know that the area of the Earth, that's including the water, obviously, is is a square about 13,000 kilometers on a side. Any questions? Everybody been able to follow this so far? Let me hear a question from. So, is everybody muted, or how's this working?
No. Oh, I'm fine from our end. I'm following up good.
Are all the other participants able to speak or chat or whatever? I don't. Let me see. Do we have a chat window? Oh yeah. Okay, I see. I have a chat window. So if is everybody's to the chat window, right? Or to the chat facility? Is that right?
Yes.
So, okay. The Timi Victor Dimeji is muted. And so somebody type in a question just to make me happy. Type in a question about what we've done so far, because I don't want to leave anybody behind. Anybody? Be bold. Ask me a question about how my cat's doing, or whether I'm thirsty. What other constants than pi do we have in R? That's a good question. I think we have E. No. EX. No, EXP1. We have EXP. I don't know whether there are any other constants. That's a good question. One of the ways you can get information from R is to type a question mark and type constants. But that probably should. And then I'll. Is there anything else you can? Okay. Yes. All right. So you can't see my window, but when I typed in question mark contents, another window opened up, a browser, and it went to a help screen, and it indicated to me that there are other constants. They're not very interesting. For example, the abbreviations of the months of the year are there. So if you ever need to label some time series data, you've got the abbreviations, the letters of the alphabet are there. So if you need those. It doesn't look like there's very many constants, though. But that's a good question. Thank you for that. But you can see, and the other thing is that if you type in question mark constants, you get, it'll say, well, I'll see how I can help you. If you just type a single question mark, then that was too specific. But if you type two question marks, then it'll go and look for some other hints that might give you that. There's some numeric constants. I don't think, yeah. There's infinity. Infinity's another constant, right? But if you type in, doesn't know what that is. So INF is a constant, whatever it is. I mean, it's kind of a silly constant, but there's some other, those are pretty much the constants. So thank you for that question. I want to make sure I keep this window open. Okay. Let's go on. And I said, I'll keep the chat window open. So if you have questions, please. And also, the other thing I will do is I will share the script that I'm running. There's not a script, but I'm going to share. I'm running from a script that I've written, which we haven't talked about scripts, but all of these commands which I'm running, I have put into a script, which is a text file, which you can look at. I'll put it up on the website. Maybe Stephen and I will talk about how to do that. Somebody said you assigned a value to a variable using less than dash. Is this standard with R? Yes. It is. What I've done is if I go up a few commands where I typed A is assigned to, yes, that is a standard way of assigning. So I've taken the letter A and I've assigned it the string of, or the expression r squared times a divided by 3 times pi. I think you can also do the same thing with equal sign. I'm going to hit return. So you could probably do x is not found, x is equal to, well, I'm not going to use x. Let's do z is not found. If I type z and I equals 6 or 5, it's the same thing, I guess. So you can also use the equal sign. I don't like to do that because I like the equal sign to be reserved for testing equality and so forth. I mean, it's just, to me, it's clearer to use the so-called less than dash symbol to represent assignment. So I probably have typed that in 100,000 times in my long life. I've been using R, by the way, for about 30 years, so maybe 25 years in various forms. So that's a good question. All right, let's go on. Let's create a variable, an object called n, and I'm going to assign it the value 2 to the 6th. 2 to the power 6. All right, so and I know what 2 to the power 6 is. It's, let's see, I count on my fingers, 2 to the 2, 4, 8, 16, 32, 64. So 2 to the 6th is 64, and if I type in n, I get 64. So I've got a constant, an object with the name n whose value is 64. Now here's something that, I'm going to show you something that R does that's very powerful. I'm going to type in the number 1, and I'm going to hit the colon command, and then I'm going to type n. So what I've asked R to do is to show me R colon n, and in the R language, that means show me all of the numbers from 1 to n. So that is a standard and fundamental idea in R, which is that if you take two numbers, like 43, 45, and you follow them with a colon, and then you put the number 50, you get all the numbers from 45 to 50 inclusive. So the colon is a fundamental symbol in R. And what is the so what I'm going to do then is I'm going to take the number, I'm going to take the character x, and or the object x, which I don't think exists. All right, x is not anything now, but I'm going to make it something. I'm going to make it the number 1949 plus 1 to n. All right, so I've taken the constant 1949 and I've added to it all the numbers from 1 to 40, from 1 to 64. So anybody have any idea? If you do that, just do that and tell me. I want to hear from people what the value of x now is. Somebody can tell me through chat what they found that x looks like. I'm looking at the chat window. I forgot to pour myself some water. I'm going to just get a cup of water while you guys work on that. Sorry to interrupt. I just go right to the bathroom and back. Okay, looks like Joy Goya got an answer. X is 1950 to 2023. That's basically, yeah, that's a pretty good summary description. And if we want to see what X is, you just type it out. Now, obviously, when we see these numbers, we think of them as dates or years or the names for years. That's just a convention. But they're just integers. They're just it's just a vector of integers. And in fact, if we want to find out some things about X now, as I can type it in, I can also look at the length of X. And the answer is, as expected, 64. Okay. When I want to look at the range of X, as expected, it's, as Joy pointed out, it's 1950 to 2013. What type of object is it? It's numeric. Now, let me remind you that any of these commands that I've been typing out, such as range, if you want to see what range does, you hit question mark range, and you won't see what you won't see what happens on my screen, but on your screen, a window will open up and it tells you in very explicit details what the command or the function range does. So it's very important the question mark is a very important command. Anything you want to know about, I guess, will it tell us anything about X? Probably not. No, it doesn't tell us. It's not there's no documentation for X, but there is documentation for range. There's documentation for class, I think. Oh, that seemed to crash my system. I don't know why maybe two. I don't know. All right. So we got range, we got class, length, lots of other things. Oh, what's the structure of class of X? It's a number. It has its index is 1 to 64. Its values, at least its first few values, are 1950, 1951, 1952. So str is another very useful command. If you want to find out what an object is, str is its structure. That's a very powerful idea, that you can actually investigate the structure of an object in addition to knowing things about it, such as its length and its mean and so forth. So the next thing I want to do is to do some simulation. If you go back to the PowerPoint slide earlier, I'm not going to try to switch windows because that doesn't seem to work very well. But if you go back to the PowerPoint slide, or if you can remember what it looked like, if you took a screenshot of it, the next thing I want to do is I want to do some simulation. And yes. Well, I accept that the fact, I'm okay, but I don't really think, I think that might be tricky because I have such a big monitor. Everything is just, well, You can try it. A little ank. Okay, that's okay. Well, I mean, the important thing is focusing on the, so you say entire screen. Well, okay, there's the, it says Firefox cannot allow permanent access to your screen. So that may be a limitation of Firefox. Let's just focus on the R window for the rest of the. I mean, we'll end up with the PowerPoint slide later on, but let's just focus on the. So okay, and remember this decision. Now it's not. So what are you seeing now? Just a picture of my silly face with. Yeah. Okay. You're not seeing the. Okay. All right. Back to the R window. Okay. Good. But all right. Maybe what I should do is try this Google sharing with my wife's computer next door, and we can experiment more with it. Not that she's interested in R programming, but okay. So what I want to do is do some simulation. And actually, let's just, I'll put in a comment here. Oops, sorry. Back here. If I want to put in a comment, if I just type in the letter comment, I get an error message. But if I precede the comment with a pound symbol or a hash symbol or a number symbol, the R command processor doesn't mind. So if I wanted to say, okay, we're going to do a simulation. So if I go back and look at this at these commands later on, I can see that command, and I'll show you how to save all of these instructions in a minute. So we've talked about how to add a comment to a session. Let's do a simulation, and now we've got X, and what I want to do is run a normal simulation. So if I type in the question mark normal, I'm looking for the normal. I'm going to do some simulation using the normal variate, which is the standard bell curve type process. And it says nothing is known for normal, but if I hit question mark normal, as it suggests, I get a window that opens up and it tells me a whole bunch of stuff. And if you look at that window, and so when you downloaded R and opened it on your computer, it came with a whole list of a whole bunch of documentation documents, and so one of the documents is listed towards the bottom is the normal distribution, and if I click on that, something's not working, but if I can look at the normal distribution, and I can see the help screen for normal distribution. So the set of commands is capital NORMAL, and then it lists for me 4 possible functions that use the normal distribution. And the one we're interested in is one called rnorm. So if I type in R, N-O-R-M, and N, I get 64 simulations of the normal distribution with a mean of 0 and a standard deviation of 1. That's your standard normal distribution. And if I type that command again, I get another 64 numbers, different ones. So you can see that the first time I typed that command, I got minus 0.29 and then minus 0.81. The second time I typed that command, I got 0.50 and then 0.84. So every time I type in R norm n, I get a different set of standard normal variates. A simulation of 64 numbers whose mean is 0, or whose predicted mean or simulated mean is 0, and whose standard deviation is 1. So I'm going to, and you know, if every time you type that command, you get a different set of numbers. And I don't know how many times I've done it, but I know that I'm not going to get the same answer every time. And if you guys do that, you're going to get a different set of values. Probably you get a different set on an Apple machine than on a Windows machine. I think maybe every time you run it, and any time you run R, you're going to get a different set of numbers every time you start R. So what I'm going to do is I'm going to, instead of this value jumping around all the time, I'm going to create an object called E, and I'm going to assign it R norm n. And there's E. And every time I type E, I get the same result because I have frozen E to be 64 normal variates simulated once and then stored in the value E. So I have a variable that is a vector of numbers. If I look at class E, it's a numeric. If I look at its structure, it's a list of numbers, 1 to 64. I think, as I said, if I typed in strx, same set. Okay, so I have E and I have X. Well, I'm out, you know, as a statistician, I am fundamentally interested in visualization. So I'd like to see something about E. I think the easiest thing to do, the easiest command in R to use to visualize numbers is plot. So I'm going to plot E. So I've typed in the command plote, and I hit enter. And I'm going to wait for somebody to chat what they're seeing there. And notice we now have two windows. We have our console window and our plot window. All right, I'm a little, as somebody who studied graph theory, I'm a little reluctant to use the word graph whenever I see this. I mean, it is a graph and it is a plot. What does the plot show? It's a plot of what?
I guess it's a scatter plot.
I heard.
Yeah, I said I guess it's a scatter plot.
It's a scatter plot, but it's true. It is a scatter plot, and usually a scatter plot is a plot of two variables, one against another. In this particular case, what it did was it plotted the value of E, but it didn't it didn't have a so-called x-axis to plot on, so it just plotted E in the sequence that the values appear. So if we look at E again, I type E, and I'm going to try to show you both. I don't know. I don't want to make this window too big because I think it's going to be hard for people to see. So I've got my, so if I look at E, I can see the first value is 1.2. That's this one here. The second value is minus 0.34, which is this one here. The third value is 1.25, which is this one here. So I can see that those values are just plotted in the sequence in which they exist. And in fact, I can plot that in a way that it enables easier to see that. I can type plot E, and I'm going to type, I'm going to do it in a certain way. So what I've done is I'm going to type the command plot E, and I want the plot to, and the plot points and lines at the same time. So now you can see what R has done. In the absence of a so-called x-axis, it's just said, okay, if you want them plotted, I'm going to plot them in the order that they were created. And then each point, each value of E is plotted at its value on the y-axis, and its x-axis is just the sequence of values, the original sequence of values. So it's, yeah, a scatter plot of our value. Remember, you know, it's, okay, yeah, I'm not going to confuse this all. Let's do something a little more interesting. Let's plot E, and then let's add the points and make them red and make them bigger. Character expansion 2. So what I've done is I plotted E as, oh, I'm sorry, I didn't. All right, well, all right, I'll do this. I plotted E as points, and now I plotted E, and I've added points. What I wanted to do was to plot E as lines, P-L-O-T-E type equals L. And then I'm going to add points to it. And I'm going to slow down a little. Okay. So what I've done is I plotted E as a series of lines connecting the points, and then I've added the points to the lines just to make it a little, and you can manipulate these plots any way you want. So I can make that plot wider. I can make it taller. I can put a label on it. Again, if you want to know how to make plots, you just type question mark PLOT, and a window will open up that explains to you how to make plots. But you can't see that, but you should see it on your own screen. So, and I guess you can right click on a plot and print it. You can save it as a bitmap and copy it into a document, into a report you're writing. You can put it into a graphics editor, whatever you want to do. So, you know, the plot's not just sitting there on your computer screen. You can actually manipulate it, save it, edit it, do whatever you want. Let's do some, let's analyze our value E now that we can see what it is. Well, let's look at it here. So you can see the values are plotted here on the along their index from 1 to 64. Anybody guess, or can anybody find out what the mean of those values is? What do you expect the mean of those values to be? The average of all those values. Actually, an easier question, what about the range of those values? The minimum and the maximum. Anybody care to guess what the, and you guys are going to have different, you probably have different results than I did because you were running a different simulation. You can control the values you get, but so what does it look like the range of those values is? By range, I mean the minimum and the maximum. So somebody said around -2. So is that Daibo, is that the range that you got on your data, or is that the range that I was supposed to get? All right, Joey said on my data. Okay. Yeah, it looks to me on mine it's about -2 to +2.2 or something. And let's just find out. Let's just ask. There's two ways we can find out about the range. We can just say range. Well, there's many ways. We can actually type min E, max E, range E, or summary E. Each of those commands gives us more and more information. Min E, max E, range E, and summary. Summary is obviously the most powerful. It says, oh, I'll give you the minimum and the maximum and the mean and the median and the first quartile and the third quartile. So essentially, you're getting the 5 quartiles, the min, you're getting the 5 quartiles, the minimum, the first quartile, the second quartile, which is the median, the third quartile, and the maximum. So summary gives you a fairly complete picture, descriptive statistics for those values. Let's not worry about that. Let's look at the let's look at a histogram. Again, if I type in HIST, I get an error message. Oh, it says, okay. I don't get an error message. If I type in the command HIST, I get a report that says it's a function which takes certain arguments. It needs one argument. And the method it's supposed to be, the command HIST is supposed to be, it's a method known to R, and then there's some information about where it's located in memory. I don't really understand that. And if you want to know what histogram does, HIST, question mark HIST. Always use a question mark. So let's look at a hist of E. So there we get a histogram. And we can see that our random normal variate, 64 instances, 64 simulations, again has a mean of 0 and a range of between plus and minus 2, which is about what you'd expect for a distribution. I mean, a standard normal variate rarely goes beyond 3. We take a lot of value, a lot of simulations to get a value, to get a range of greater than 3, but it's always going to be around 0, and it's always going to have a standard deviation of about 1. That's not a normal, that's not obviously a normal histogram, but it's one that is close to being normal. It has roughly 1 mode. I mean, you might argue that there's 2 modes there, but not a big deal. And histogram is an extremely, we've looked in terms of generating graphics, we've looked at two commands, plot and hist. You can also add things to hist. For example, you can do x limits equal to -3 and +3. Let's add a title. Main title equals simulation. So I've typed in the letter, I've typed in our command E, I've given it several options. I say I want the histogram plotted not on an axis determined by the values of the variable, but on an axis determined by limits -3 and +3, and I want to give it a title. So now you can see we get pretty much the same histogram, but it has now been confined to the range -3 and +3, and it has also been given a title, simulation. And again, all this stuff you can find out about by typing $E. So we've got a way of visualizing the data. So let's see, what do we want to do? Let's put some lines on that variable. Let's type in quantile E, which again are the 5 quartiles. I misspelled quantile. All right, there's the 5 quantiles: the minimum, the maximum, and the 3 other quartiles. But let's put those quantiles on the histogram. So I'm going to type AB line V equals. So it's going to place vertical lines on the histogram, and let's make them red. And let's make their line width equal to 2. And let's make the line type equal to 3. So I'm going to say, on top of my histogram that's already plotted over there, add vertical lines at the quantiles, color them red, make them twice as wide as normal, and plot them with a dash. Maybe that wasn't big enough for you to see. I don't know. Let's make it 4. What the heck? All right, I'm going to type it again. Just hist. Here's my histogram, and there's my last. So there is the histogram with the 5 quantiles. And again, you can see the histogram itself goes beyond the minimum and the maximum because it's trying to make bars that span the range of the data. And we can see that our median line is somewhere in the middle, pretty close to 0. And then our 2 quartiles. So we just want to stop there and say we've made a plot, and then we've added information to that plot. I said we were going to do a simulation. We've already run a simulation in the sense that we've created 64 values of R. 64 values random normal variates. But what I want to do is we've got X. Remember our X? Go back to X. Those are our so-called years. Now I'm going to associate with each of those values a value Y. And I'm going to assign it the values -3,000 plus 2 times X plus 16 times E. So I've taken the value Y, I've assigned it the value minus 3,000. I've added to that 2 times X, and I've added to that 16 times E. And if I've typed the command correctly, nothing should happen, which is a good thing. It's one of those situations where if nothing happens, that's a good thing. So nothing happened. But I now have the value Y. And if I type in Y, I can see it there. And let's, as usual, I mean, we can do all kinds of fancy things like means and standard deviations and summaries and structures and so forth. But, if you want to know something about a object, particularly an object that consists of more than one value, plot it. I'm not going to plot it here because I want to ask you guys to do that and tell me what you see. So I'm looking at the chat window. So plot Y. First create Y based on, and I hope you can see what I've typed there, and then plot it and tell me what you see. I have 9 people listed in the meeting, and I'm waiting to hear from, I'm waiting to get a chat from somebody. Anybody? I'm here, drinking my water. So everybody but me and Stephen are muted. Is that the story?
Hi, Lee. Basically, yeah, I just came in. I actually did not get I didn't really see the link. So Steven just shared it with me now. I'm so sorry for coming in this time. So I hope everyone. I hope everyone actually installed the R Studio or the R environment and are trying to follow. We actually tried our best to make sure this happens. So I'm hopeful that you guys are following through with what Lee is trying to talk about, because we're trying to bring the R programming language into the community so people can have an option. So please, this is an exciting one, and please contribute. Thank you.
Great, thanks. Yeah, I'm waiting at the moment for somebody just to put a chat comment in about what happens when they plot Y.
Okay.
So,
okay.
Yeah, I'm just waiting for all it takes is one chat, and then I'll go on. But I'm stopped. You can speak out audibly, or you can type in a chat to what you see. Just describe what you see when you type plot Y, when you execute the command plot Y. You can see how patient I am. I'm used to waiting for answers. I can't. My browser won't let me. Won't let you what? Oh, you're talking about muting yourself. Okay. You don't have to. I mean, just type in just somebody type in a chat for what you see when you type plot Y. could say nothing, or say a yellow squirrel doing cartwheels. Watching the chat, but everybody has access to chat, is that right? Okay, so is everybody able to generate the value y? Yes. Okay. I got a answer. I got a yes. Okay. So when you plot it, what do you see? See a scatter diagram. What's the scatter diagram show? Scatter with a positive slope. Whoa, I like that. That's good. That's good. I hope I get the same answer. I'm going to hit enter and see what happens. Obviously, when you say a scatter with a positive slope, you're adding a lot of interpretation there. But because we created y as a function of x, and then we added 16 times. The first thing we did was we plotted y as a factor, as a function of x, and we subtracted 3,000 from it. And then we added 16 times our e value, our random normal variable, and we get a scatter diagram with a positive slope. Or we're going to talk about what we mean by slope in a minute. We only have about 10 minutes, so let's kind of cut to the chase. So let's add our x variable, and what I want to do is create a new object. You can run R routine here, R snippets, R online. Oh, you can run R online. Oh, great. I'm not going to go there. That's not today anyway. So I'm going to create a data frame. Over here. Well, let me just stop a second and say, if you've been typing on your window and you want to save all the work you've done, you can type in save history, and then you need to give a title, any title you want, but R. I'll just give it the title R. Nothing's going to happen. I mean, nothing. It's not going to show me anything, but it has saved a history script. So if I go open script and I go to my archive, there's everything I've typed up to the beginning of our session. All right. So by typing in the command save history and then giving that history a name, I've created in some place on my computer, might be in your documents folder or wherever, I've saved a script that has everything I typed up to now. So before you terminate your session today, you could type in save history and get every command you typed in. And then you can see the comments that we typed in here and all of the other stuff that I typed, much of which was not very useful. All right, so what I'm going to do is I'll give another comment, data frame. And I'm going to create a data frame called DAT, and it's going to be a data frame consisting of X and Y. Right? Very powerful technique. It just takes X and Y and glues them together. No, didn't give me any error messages. And if I type in DAT, I can see what DAT is, but obviously I'm getting too much detail there. So I'm going to just type in the head, the first few, the first 6 values. And there's our our data frame. Class, it's a data frame. Structure, it's a data frame with 64 observations and 2 variables, X and Y. And if I plot the data frame, I get the same picture, except that now I have an X variable on the X-axis and a Y variable on the Y-axis. So R knows, I mean, because R is an object-oriented language, it knows what to do with a data frame. If it's a data frame with 2 columns, data frame can have many columns as you want, but if it has 2 columns, it'll plot the second variable against the first variable. And again, I can put a title on there, so I could go over here and I could say type DAT main equals simulation sim time series. So there's my plot, and I can plot it with lines or whatever I want. So it is a time series, only in the sense that I made it look like one. It's not actually it's neither a real time series consisting of real data, nor is it what R would call a time series, because that is a certain kind of object. And I can look at the summary of the data, which you've already seen. Here it is combined. It says X is a variable that ranges from 1950 to 2013. Y is a variable that ranges from about 890 to about 1100. And I'm going to do one more thing, and then we're going to stop, because I said we were going to go for an hour and a half, and I think probably people have had enough. I can look at a linear model of Y versus X using the data DAT. So I've said, give me a linear regression model using the formula. That's a formula Y versus X from the data frame DAT, and it gives me the result. All right, I know that's throwing a lot at you at the 11th hour, but if you do question mark LM, a window will open up that tells you what that gives you some information about what's going on there. And indeed, if I want to visualize that, I can type in, I think I can type it in, let's see, AB line. So I want you to plot a line on that data, a regression line on that data that estimates the value. So if I run a regression on that data frame, it says that I have an intercept of minus 2,964 and a slope of 1.9. And if you remember how we created Y, if you go all the way back to where I created Y was created, if I scroll up, if I did a lot of fussing around there. Wait, where did I? Well, maybe it was later. Where did I create Y? It's kind of buried here. Oh, here's Y. I created Y as being minus 3,000 plus 2 times X plus 16 times E. That was what I was. And the regression line through those points gives me my minus 3,000, except that it's not minus 3,000, it's minus 2964, and it gives me a regression coefficient of 1.98, which is pretty close to 2, and I was able to fit a line through those points. So that's pretty much what I wanted to do today. I mean, we could spend, I don't want to push you. I think we've covered a lot. So let's kind of wrap it up. We have 3 or 4 minutes before my 11:30, your 15:30. So how did things go? I'm going to check the